Cool. So this is 5.8, computing an alternation. Alternation. The prompt of this question is, given an array of numbers, say like 1, 2, 3, 4, 5, it can be in any order. Write an algorithm that makes it so that a at 0 is less than or equal to a at 1. And then this sign is actually switching here. So and that result is greater than a at 2, and so on. And then they keep switching the sign. A at 3. And then a at 4. It's essentially asking for local minimum and maximum throughout this. So if you get the approach right on this one, the implementation's not that bad. One brute force solution would be to sort it, right, which is O of n log n. And then, it's sorted. And then you could just say, okay, start from the middle and choose like the 3, add it into a list, and then add a 4, and then a 2, and you could just alternate like this, keeping pointers. And that would satisfy the condition of the list. It would be O of n log n runtime. And then also, it'd probably be O of n space if you were gonna have an additional result array. So if you're trying to beat that, you might be able to come up with a better in-place solution. But looking at the question, here's like without getting too mathy, let me walk through a portion of the question. So if we have to start at a low value and then go higher and then lower and so on, we don't necessarily have to have an increasing highs and decreasing lows, or even something like this where we have to start at the highest. The only boundary condition is that this guy has to be greater than these two, greater than or equal to. So about as loose as a condition as we could get. If we went through and we wanted to do this by hand, with our brain, we would first look at how would we do it? So we'd first look at these two and we'd be like, okay, we need to start low, and then this one's higher. So this actually satisfies the condition. Moving through, we would say, okay, looking at 2 and 3, that doesn't work because this needs to be a high. See, it's supposed to go low, high, low, high. So what could we do? We could swap them, but then wouldn't we need to deal with cascading effects to the left of that? And here's why we wouldn't. So say we swap. It goes 1, 3, 2. Think of our original array, these values as A, B, and C. So anytime we've passed on, say we can assume that A, this was supposed to be low, A is less than or equal to B if we've moved on, regardless of whether we swapped right here. So now when we're moving on to here, if B is greater than C, so high, low, great, we don't need to do anything. But if that's not the case, that means B is strictly less than C. And then combining these logics, that implies that A is less than C. Which means this condition right here if we swap these to be A, C, B, we know that A is strictly less than C. And then we already know this from this condition we just tested, so B is less than C. And we get our local minimum and maximum. And the same works in reverse. So say this next value was actually 0. Say we were comparing these, and this 0 needed to be a local max. If we swap these, I mean, we can just see it would be low, high, low, high. That would work out, but also that would say if we swap those, that would imply that the previous D was less than C. That didn't really go anywhere, but the good news is that at any step, all we need to determine is if we need to swap it or not. And if we go through in one pass, it should work out. So the code with that approach should be pretty simple. So we'll have to go through the list once, and you can start at 1 or 0. I'm going to start at 0. A.size, and we're going to look at, see, if we're going from 1 to 5, we want to be looking at every combination of 2. So I'll say I should go to here, so less than size minus 1. And our safety in this is we can look at I and I plus 1 as we go through. So we just need to really compare based on whether we're in a low-high sequence or in a high-low sequence, what we should do. So one would be the low-high. So how do we know that? So if we're take the first example, I is 0. So if I is even, basically, I mod 2 equals 0. And things are not in the correct order, so a dot get at I is actually greater than a dot get at I plus 1. So not like this case, but say it was 2, 1, we would need to swap that. So in this case, we would say just, collection or dot swap from list A, I, and I plus 1. So that's the low-high case. And the high-low case is the exact same thing, except we're going to be doing it on an I, or on an odd case, and this sign must switch. That's the whole problem. That's it. You could combine these into one statement because we're really just doing the same collections.swap here. In an interview, I would mention that, but I wouldn't combine them because it might take some time if they don't let you use a laptop. And I think the logic is actually clearer this way. But you would tell them, I know we're repeating code here. Running our test cases, everything pass. So that's computing an alternation